Hello friends, today our teacher is Mr. Pramod Kumar. Mr. Pramod Kumar is a former additional director of the Atomic Minerals Directorate for Exploration and Research, AMD. He has over 37 years of professional geology experience, mainly exploring for atomic minerals, namely uranium, rare earth. He has worked in diverse geological terrains of India, exploration for uranium in quartz pebble conglomerate, unconformity type, vein type, carbonate hosted. He has been part of several uranium discoveries in India, including Tumulpalli in Kadapa district. Welcome, Pramodji.
Thank you.
Thank you.
Good morning.
Now we are today going to discuss what are the common field mistakes that people do, that explorers do in the field, and that might lead to a distortion in the exploration database, or a failure, even a failure of exploration data. So, the first thing I would like to ask you is, how would you place the importance of field work? And is it true that interest in field in general is declining?
Yeah, I think it's a very pertinent question. This we have seen in a number of cases, even in faculty members and the students and the interviews which we have taken. So normally we see that the component of field work is definitely declining, and that is not a very happy situation, I should say. And unless we go to field, we cannot learn anything. There is a saying that deposits have been discovered by the sole of the boot of a geologist and not by the seat of his pant. So, sitting in a laboratory and finding a deposit and finding something of importance is not going to help us. So, definitely, the good geologist is one who has seen maximum number of outcrops. So, the more you see, the better you learn. So, the synergy between the laboratory work, the armchair work, but field is a must. And one more thing I can say, that it's a really very enterprising and thrilling experience once you go to field. So importance of field work, we just cannot do away with. Definitely, surely.
How do you plan for traverses? And how do you
Well,
equip for field work in general?
yeah, that's a good. See, the first point is that we must know what is my purpose of going to field. So whether I'm going to search for a deposit or a mineralization, or I'm going for an engineering geology work, so that is very important first. So before that, we must know the literature part of it. Nowadays, there are published data for every field almost available. So as much as possible, we must do the survey for the literature. Thereafter, the stratigraphy of a place. I always say that stratigraphy is mother of geology. So unless I know the stratigraphy and the structure, so these two things, first is your literature, second is the stratigraphy of the area that I'm going, and the structure there. So these are my planning, and then acquire the knowledge. So when I go to field, I will see what I know. So unless I know something, I will not see anything. So that is very important. So this is how we should. The second thing is, know your compass. I always say this Brenton compass, or any clinometer compass, whatever you are carrying, it is very important. It is just like a stethoscope of a doctor. Then the scale of your operation, on what scale you are going to work. So whether it is a reconnaissance work, whether it is a detailed work, or it is a work of a nature, like I'm going for a mining. So whether it is 1 is to 25,000 scale, or whether it is 1 is to 10,000 scale, or whether it is 1 is to 500 scale. So with that scale, my aim and purpose, we must plan our field work.
So scale plays really a very important role. Is that the size of observation, or what are the observable objects at every scale? They would be
Yes,
different. So
absolutely, yes.
what we can observe and map as 1 is to 50,000 is very different from what we can
Yes,
do at 1 is to 1,000. Yeah.
exactly. And because that will define my purpose. So scale is absolutely very important.
And is are there any risks involved in field work? Safety risk? Is the field work risky, and what precautions one should take normally in general of going to the field work, before going to the field
Yes,
work?
yes. Many young boys, they feel that, yeah, it is very risky and going to field, and then we may face wild animals and blah blah blah, so many things. But let me assure you, it is not a risky thing. Only thing is our planning is very important. I always say that 3C we should take care. 3C, your first C is your camping. Your second is your clothing. So you must camp in a place which is safe, and you must know your surroundings everywhere. So camping is very important, clothing is very important, and your cooking is also very important. So if you take care of these three C's, you have not to fear. You don't have to fear. Before you go to any area, make sure that you talk to the local administration there, or the forest officers, or even a village sarpanch, village headman, so that your presence is known there. And always engage a field guide which is local from that area. So once you have taken care of these three C's, you don't have to be afraid. Of course, on a very minor scale, we see in the country that there are some terrorist activities or insurgency or Maoist, etc., but very little. So it is always better that you talk to the local administration, talk to the local pupil, and then fearlessly you can go to field. Absolutely, there is no problem.
But this also recalls me. You mentioned about the wild animals. I recall that once I was doing field work in Australia. So they used to have actually a chart of what kind of dangerous animals or snakes or
Yeah,
scorpions or spiders to look out for. Which are how to identify them. Which are the safe ones. Which are the unsafe ones. What you can don't need to bother about and where you can need to run away. All that was displayed on a chart.
absolutely, yes, absolutely, yes. But I can tell you one thing. If you see the entire history, no geologist has been bitten by a snake, and 90% snakes are non-poisonous. It is only 10% snakes which are poisonous. India, we are living with snakes for thousands of years, but our knowledge about snakes is very poor. So it is more of a psychological thing rather than the real physical thing that we are afraid of. And second part is that we are not the natural prey of snakes. The moment the snake will see us, he will run away. So absolutely, we don't have to fear. I can tell you in Western Ghats, I have worked for a few years, and it is a den of snakes. Religiously, every day you go, you will see 10 or 15 snakes. Absolutely, every day you will see. But no snake will come and chase you in the field. Snakes will run away the moment you see. So we are more dangerous to snakes rather than snakes are dangerous to us.
Okay, let's say we safely make it to the outcrop without without getting bitten by a snake
All right.
or
Yeah, yeah.
let's presume we are
Okay.
all safe. So
Yeah, yeah.
when we get to the outcrop, what are the things that we should observe and what are the important things to note?
See,
Obviously, depending on scale.
absolutely. So I will say first that finding an outcrop itself is a challenging thing. You may not find an outcrop because the area may be soil cover or the area may be a thick forest. So finding an outcrop is the first challenge. And once you find the outcrop, then your work begins. The first precaution that we must take is to assess whether this outcrop is in situ outcrop or a displayed outcrop, whether it has been faulted, it has been dislocated from its place, because unless we make sure that the outcrop is in situ outcrop, all our observations will be wrong. The second point is sometimes we can also see the well cuttings, supposing a big well is there, or a road cutting is there, or some blasting has taken place. So all that give you the nature of the real outcrop. So the first observation is that find out the in situ nature of the outcrop. The second thing is the contexts, the different contexts in the lithology. So for that you have to assure that you must know the attitude of the formation. So place your compass on a plane, on a joint plane or a foliation plane, where you can see at least it in the two directions, so that you are very sure about the plane. Place your compass there. Don't see it from a distance. You place it on the outcrop, see it and measure it, the strike where the dip is 0, 0, very conventional thing. But you must do it very faithfully. So locating an outcrop is important. Then must see whether it is in situ, must see whether it is structurally disturbed, or some folding or faulting or pollution, everything you must see, and that makes your job very easy.
I recall one example that I think we discussed when we were doing one field work together in Kadapa. You explained about the importance of surface slump while measuring dip direction and dip amount, and that has led to missing some of the deposits in drilling. So can you explain that a bit?
Exactly, yes, yes, yes. Because that is, you see, we cannot overlook the conventional point here. The basic thing is when we go to the field, you locate yourself, use your compass, see the outcrop, basic features of the outcrop, which are very easy to see if you are conversant with them. So make yourself conversant and do record your observations very, very faithfully. And permit me to give an example. So why our observation is very important. We may not be knowing the exact nature of the geology or the mineralization there at this moment. But if we record it faithfully, sometimes somebody may make use of it. See the Singhum uranium copper mineralization, the Singhum shear zone. I tell you one in 1920s, one private prospector by name Murray, he was prospecting there for phosphates, apatite mineralization. He mentioned in his diary that there is a secondary uranium mineralization, possibly torbornite. It is a copper uranium phosphate. He just recorded it. 30 years later, geologists discovered that it is not a secondary uranium mineralization, even primary uranium mineralization is also there. And today, we have discovered a uranium metallogenic province in the Singhum shear zone. So his observation was so important. Second example is from Rajasthan. And this Rajputana, it was called that time, AM Heron. He recorded that some red color outcrops, which are unique, and they are in a linear fashion, they are seen in the field. And he has recorded it, and then some felspatization may be there, and red color. Later on, GSI Dr. S.K. Ray, he established that this is actually a zone of albitization. And along that albitite line, AMD has discovered many uranium deposits today. Rohil is one of them. So albitization was not known that time, but when it was observed, based on his recordings on the outcrop, we discovered that it is a zone of albitization and a causative factor for many type of mineralization. So your observation is very important, and recording is also very important.
And maintaining the record for over a period of a long time, so that even after 20, 30 years, people can use it and make a
Absolutely, yes,
discovery.
yes,
That's
yes. See,
important.
records are very important.
Correct.
Every record is important. Your field diary is very important.
Hmm.
Sir Oldham, his field diary are still, I think, preserved, and he has made beautiful sketches in his field diary, the drawings, etc. So you can always know the geomorphology of that area where he has visited. It is very important.
What can be the usual pitfalls during mapping and during making these observations?
What for you are mapping, and what is your scale? The scale defines everything. If it is a large scale, your field traverses have to be very important, and number of traverses you must take. And the first thing is, when you are walking in a jungle or you walking in a field, mostly we lose our direction. So you must know whether you are walking along the strike or walking across the strike. It so happens that you are walking along a strike, so you will continue to see one bed. And if you are walking on a dip slope, by mistake, you may say that this mineralization is very thick and very long, whereas actually its true thickness may not be that. Secondly, when you start your traverse, I used to say that if you are going from place A to B, then come back from B to C. Don't come back on the same way, so that the more observation you record, so the more things you see, the more outcrops you see, and record all the data. And when you come back in the evening, plot it. Don't defer it for next week or tomorrow or this thing. You plot it today itself in the evening, so that you can revisit the area, you can interrogate your own observations, and what more you have to see. So these are very basic things that we must observe while doing mapping.
After mapping, the most important thing, second important thing is sampling. Now, the sampling is done for many different purposes.
Absolutely.
One purpose is important purpose is at least pick up the rock that you cannot identify, so you can do some tests or consult others and identify
Absolutely.
that.
Yes,
Then
yes,
again,
yes.
you can do some
Okay.
petrological sampling on that, or maybe do a systematic grid geochemical sampling for mineral exploration.
Yes.
So,
Yes, yes.
what are the different kinds of samplings, and what are the common mistakes that people occur during this sampling?
Yes. Again, I will say there are three P's involved in this. That is your purpose. What is the purpose of your sampling? The second is you must prepare your samples. And third thing is you must preserve your samples. So three P's are very important. And McKinstry has said in 1960s that all samples they deserve respectful treatment and perpetual care. Now coming to the basic things, once you collect a sample, make sure that it is from a fresh part and not altered. So the mistake is that we collect a sample from anywhere, and then it comes out to be a weathered portion of it. So as far as possible, collect the sample from unaltered portion of the outcrop. Trim the sample. You decide, say, I want to carry a sample of around, say, 4 inches by 3 inches by 1 or 2 inches. That size is good enough. Then your scale of operation. If I am going for a reconnected survey, well, I can just collect 2 or 3 samples per square kilometer. But if my scale is a very large scale or a detailed scale I am working, you have to collect more number of samples. And sampling is a very dynamic process. It doesn't stop from exploration stage to mining stage to milling stage, or start from your survey stage to grab samples you collect, random samples you collect on a grid scale, systematic sample you collect. So these are very important. So keep your purpose in mind and preserve your samples very well, treat them very well, and bias in the sample. What happens when supposing I am going for a survey for finding a copper mineralization? So the moment I see a rich copper mineralization, I collect a sample from there, and then they ignore the sample which are from a very less concentration. So that is not. And then we give analysis and we say that my range of this thing grade is say from 1% to 10%, but that range is biased. So what I have to do is that unbiased sampling on a systematic grid you collect and then you analyze. So there instrument bias can be there, analytical bias can be there, but bias we should not introduce the bias. We should be very dispassionate. So collect the sample dispassionately on a regular grid pattern depending upon your purpose, and then analyze it. The samples have to be representative samples. Samples have to be fresh from unaltered locations. The samples you must preserve and label it and collect with a purpose, preserve it. And I repeat again what McKinstry says, give due respect to your samples, preserve them for perpetual care. Care your samples very well because they are what exactly they convey you the meaning, the purpose, and perpetual care and due respect to the sampling program is very, very important.
Is not only sampling bias, there can be bias in observations also. So can you explain slightly in the
Absolutely.
observation bias also?
Absolutely, yes. That is called a human bias. So that's what I say. You should not introduce that bias. It is incidental to your process. It may be there, but then the instrument also will give some error. Your analytical method also will give you some error. So that is inherent. But introducing the error myself is very bad. What I normally say is there is no error if you know the error. If I know that this is the error, then there is no error because that becomes my limitation. But introducing the error is very bad thing in mineral exploration.
Good. So finally, what advice would you give to young geologists that are just going to start exploration, their career in exploration?
Yeah, it's a good thing that I say that field geology and survey is a very adventurous profession, very exciting and thrilling. Only thing is we must know it, and we must develop that passion. As I said it earlier, that I should love to go to field and not that I have to go to field because my boss has said or my company has said, so I am going. No, you must develop that passion for your field work. That is one thing, and it's a wonderful outdoor activity if you know how to enjoy it. And then we must be very optimistic. We beat the all odds you beat in the field. Don't be afraid. Be very professional. And yes, professional ethics is very important. And above all, if you enjoy your field work, you will enjoy your very good health. Vadia, our late Dr. D. N. Vadia used to say, those who have done good work, they have earned their health insurance. So you will be very healthy if you do good field work.
And be safe so that you don't injure yourself. So that's part of the safety procedures. Yeah.
Thank you. Yeah.
Correct. Okay.
Very nice.
So yeah, thank you so much, Pramodji, for giving such an enlightening talk.
Oh, it was my pleasure, Dr. Amit, and I must congratulate you that you have chosen this very important subject, which is most neglected, that to develop the passion for field work, and then what are the common errors in that, and then give a good boost to the young and budding geologists who should do more and more field work.
Thank you.
That is rewarding. Thank you very much.
Thank you for watching the video. I invite you all to please visit the Mineral Exploration Academy website and register yourself. The registration is free and registration is open to students, teachers, professionals, or anybody who is interested in mineral exploration. The registration will also provide you an access to be able to ask questions from our experts and also provide an opportunity for established experts to answer and interact with the students. The registration form is available on the Mineral Exploration Academy website. I would also encourage you to look at the editorials and opinion sections and visit the student question and answer section at the bottom here. In the student question and answer section, the questions asked by the students are being answered by our experts. Our experts are the top people in the field, and it would be a wonderful learning opportunity for the students for probably the questions that occurred to you but you could not ask, or to review questions what have occurred to other people and get the answers the different experts are providing. Thank you so much, and I look forward to interacting with you a lot more.